Hey guys, what's up? Eddie Aho here with KissAnalog.com. Alright, today on the bench here I'm working on a power supply design, and when I power these things up I like to have a lot of meters on them. So yeah, I do use a lot of meters. I'm not using all of these meters, but I use a lot. I've got temperature readings going on, voltage readings going on, and I just want to make sure everything looks good as it's coming up. I even have my thermal camera over here, so I can, as I'm sitting here letting the thing warm up, I can make sure nothing's getting a thermal runaway. And I'm just pretty careful when I power things up. Well, I'm using this Hantek current probe, which this guy's been great. CC65, I think it's only around 60 bucks, $65. It's a really affordable current probe. But I'm looking at frequencies close to 200 kilohertz. And this guy's only rated for 20 kilohertz. He goes past that. The amplitude might not be quite accurate, but it's close enough that I use it outside its range pretty often, actually. Well, in this case, it's too far out of the range. I mean, it's almost 10x. So he's kind of giving me some funny looking readings. So yeah, I've got the Micsig over here. He's a wide bandwidth current probe, and he's perfect. So I can move him back and forth and check and verify that I am getting readings that are just too far off at this. So turns out I've got another current probe from Micsig. They actually gave me this one to do a review once. I thought that was super nice of them. I'll put links down below for these videos, but they gave me this one. So yeah, I just thought, you know what? This is a great time to pull this out of the box that it's been sitting in for a while now. I've just been too busy to look at it. Now, they gave me this one. It didn't come with any documentation. What happened is they had sold it to someone who had had a problem, and so Micsig told them to return it. But then they thought, hey, why don't we send it to Kiss Analog and see if he can fix it and do a review on it if he wants. So they just said, hey, we got this meter, it's been returned to us, we'll have them send it to you instead, and you can do what you want with it. So I'm going to. The switch, it's kind of stuck. So I'm going to first take it apart. Hopefully it's a simple fix, because I want to use it. And if all else fails, maybe I can put it into position that I might most commonly use it in and just keep in that position. I'm sure I could get a switch and eventually fix it, hopefully. We'll see what's inside this thing. But yeah, you never know what happened, where it went, the home it was in, and how it was treated. You just never know. So yeah, I kind of got it returned in this plain Jane box. It looks like a Micsig box, but usually they have a sticker over it. Now this is the ACP1000. I think that's right. Yep, ACP1000. And it has quite the current range. There's actually 4 different positions on this one, where most of them have 2 positions. This one has 4 because it's capable of going pretty high in current, but it also goes pretty low in current. Now here's another catch. This guy's rated at 100 kilohertz. Pretty decent, but not good enough for what I'm using. But as this guy has operated outside its range, we'll see if this guy's, if it looks like, let's say I'm looking at a triangle signal. If the current is triangular shape with this guy it's not. With this guy maybe it is. And if the amplitude is 20% off or 30% off, I might be okay with that. I just want to watch it as a relative measurement when I'm doing these kind of tests. So sometimes it's okay to use things that aren't giving you accurate measurements if you want to use them as a relative measurement, if you understand what I'm saying here. So I just want to see how it changes as I'm powering things up and changing the load. I don't need to know the accuracy of the measurement, but I do want to see the proper shape. And this frequency is just a little bit too fast for this, so this guy's not giving me the proper shape anymore. That's one of the things that happens when you operate any kind of probe outside of its range. Usually you start getting roll off, you know, a kind of a filter roll off, but also it can be outside of the range where the thing's capable of even measuring it. So it's at some point it's not even an amplitude error, it's just everything's out of whack, which is what's happening right now. So let's go ahead and bring the camera over, open this bad boy up, take a look inside and see if we can fix it, and then see if what kind of measurement it gives me at almost 2x its rating. Okay, let's do it. Okay, here's the case that came in, and looks like a fairly long cord. That's nice. They always have, you know, their cords always feel like quality, like silicone, or, you know, there's voltage ratings on this thing. Oh, this is a RG58/U. And look, it says quality coax. Has to be quality. But no, it does feel nice, and it has a nice BNC connector. Okay, you can see there's multiple positions on this thing. 1x, 10, 100, and well, maybe it's only 3. I don't know. It's hard for me to tell right now. There's 1. It almost moves to the second one. Yeah, it's hard for me to tell actually. But here, let's just go ahead and open this up. Okay, it looks like there's 3 ranges. From down, you know, for this table right here, looks like 3 ranges, which is nice. It's 1 more range than a lot of the probes. Now this guy here, it's a pretty beefy, fairly heavy probe. It's got some, you know, whatever that is, ferrite, whatever is in there. Okay, and yeah, there's a little sticker, but man, looks like there should have been something here. There's only 2 screws holding it together. Yeah, that sticker is holding it together. Whoa, okay. Dropping the screws in the box there. That part looks fine. Moves up and down. There's our switch. You know, it could have been that this thing just jumped out of position. You know what? That's perfectly fine. You know what happened, I think, guys? Now, I wouldn't be too surprised if somebody reviewed this meter, took it apart, put it back together, and didn't get that switch located properly, and so it was stuck, so it couldn't move. And then they told Micsig they wanted to return it. Now I'm playing detective, I guess, but alright, so it looks like there's a bunch of diodes up here for some to rectify the voltage, I'm assuming. And it looks like they did kind of an interesting arrangement here. There's 2 stacks of resistors, maybe to get the right resistance. And then there's 3 pots for calibration for each range, I guess. Okay, there we go. Yeah, I don't know if someone's worked on this. Look, there's a bunch of resistors on this side. And it looks like some no flux or no clean flux has been used, which I haven't noticed that on their other devices, but I think I'm going to take some alcohol and a Q-tip and clean this up. I'm just looking to see if I see any damage. I don't see any damaged parts, but it's kind of hard to tell. I'll look at it with the loop, okay? But yeah, there's the 2 sides of the board. There's one side of the board there. You can see that resistors there. This side looks fairly clean. There's a little bit no flux, or no clean flux it looks like. There's a tie strap holding this cord down, so tension relief on these two wires here. But yeah, this side needs to be cleaned and then inspected closely. I'll make sure nothing's pinched or broken here. But yeah, this looks like an easy repair. Okay, I just moved the box away because that foam, I'm sure, probably get damaged by this alcohol. This is just some isopropyl alcohol. I'm just gonna see if I can clean it up a little bit. We'll hit this side too. Try to avoid that switch. Although it's just alcohol, it should be okay. Okay, I'm going to just bring this up close so we can look at it together. Alright, so that's what it looks like now. Just took a little alcohol to clean up that, I think it's no clean flux. Yeah, looks like it's in pretty good shape. I'm going to try to put it back together. Just going to take a nice close look in here. Okay, looks like the first thing to do is to put this guy in and try to situate this board down in here. Alright, that made sense. There's some pins, some plastic pins that reach up and push into the board here. See, there's one right here. There's several pins in this little guy here, and I think they are supposed to. So I got that pin in that hole. Gotta try to get them all in. Okay, there we go. Gotta get one down here somewhere. Okay, it feels like they're in. Feels like that board is situated now. Get this little guy here. This is our stop here so that we have some tension relief on that cord. And then I'm going to slide this all the way into down position. And then I'll slide this all the way in the down position, and hopefully this lines up. There we go. That looks like that works. Yeah, that's all it was, guys. It looks like somebody had taken it apart and not put it back together properly. So, there we go. Now I just got to put the screws back in. Some decent length screws here. And just drop those in. That was almost too simple, right? I don't know what that sticker means, but maybe it's the serial number, but there we go. All good to go, and it works. So I guess this is where you set your scope, times 100, times 10, times 1, and this is 10 amps, 100 amp, or 1000 amp range. That makes it really simple to figure out. Sometimes you only get this, sometimes you get this, and you have to figure it out. Well, and then you also have this, so this just puts the two things together, I guess. It's 10 amp, you get 100 millivolts per amp. 100 amps, 10 millivolts. 1000, 1 millivolt per amp. So we're going to be down in the lower range. I'm going to leave it right here. Now, this tie wrap was used for the power cable. Usually I think we get Velcro ones with Micsig, or at least some of the probes I've seen. So I think somebody just put that together themselves. But yeah, there you go. Pretty nice cord. Feels good. And it's pretty long. Okay guys, see this waveform here? This purple one, or whatever color that is? That is supposed to be a triangle waveform. And that's what I was getting out of the Hantek, just because it's rated at 20 kilohertz, and this is 183 kilohertz. So yeah, it's hard to blame the Hantek for not doing what it's not supposed to do. And there's a Hantek's jaws, nice size. That little loop I put in there, but just too far outside the range. Look at those jaws. It's a good thing I put a big loop in there. I think it'll fit. See the arrow right there? So I think that's the right direction. Alright, that's what it looks like. Now let's go look at the scope. Okay, I'm going to have to unfreeze the scope and let it start triggering again. Alright, we'll bring up power. Whoops, let's drop the amplitude. Alright. That's on times 100, that's what the problem is. Alright, there we go. I'll freeze that. Okay, it's almost triangular. It's not quite the way it's supposed to be, but it looks a lot closer, and the amplitude looks more believable too. So I think this looks better, and that's almost double the frequency of what it's meant to be, or what the Micsig ACP1000 is spec'd for. Okay guys, and this is a Micsig CP2100B, which I've done a review on before. I'll link that below. But let's go look at the scope and see what it looks like. Okay, the Micsig was plugged in channel 4, and nothing's hooked up right here on channel 3, so I'll just turn that off. Let's go ahead and power up. Okay, I'll freeze that. Okay, and that's what it's supposed to look like. So this guy looks like it's going 1, 2, 3, 4, 5, 6, 7, a little over 7 amps, and it looks a little more triangular. You can see there, it's not quite, there's a little funkiness on the edge, but pretty close to triangle. So the amplitude of the Micsig had dropped a little bit, but I mean the ACP1000, and it did look a little bit, you know, more funky at the top, where this one's doing this transition, changing. The ACP reacted a little bit more to it on both ends, but it's closer, and we're operating almost 2x out of its bandwidth, but we're not 10x like we were with the Hantek. So nothing against the Hantek, just 10x out of its band. The ACP's 2x out, but I think it's usable. So, alright, great. Alright guys, so what do you think of this guy? It's a monster, it's a beast, right? I mean, well, you know, it's go up to 1,000 amp range. I mean, that's pretty incredible. But you know what? What's really incredible is that it can also operate all the way down, you know, in the 10 amp range. So 3 ranges of this. Has that extra range for that high current, and it has a nice strong, you know, jaw. I like the design of Micsig's products, and you know, hey, they gave them to me too, so you always like something you don't have to pay a lot of money for. Okay, cost wise, I think this guy is around 240 bucks US, and I believe it's a fairly new product. I hadn't seen it before, and when I saw it, I asked Micsig about it and said, hey, would you like me to review that? And they didn't have any. They said, well, I think the story was it was fairly new, and they were selling pretty fast. This is before you know, the holidays, Christmas. But then I got a call, lo and behold, and they said, hey, guess what, we got one coming. And you know the story I told you already. They asked me if I wanted to try to repair it, and when they told me what was wrong, the switch, I'm like, heck yeah. Even if I had to solder you know, the thing in one position and only using that position, heck yeah, I'll take a free current probe. But that's all they said. They didn't, you know, and I haven't heard anything from them since then. Well, they asked me if I received it, and I said yes, and then after that, nothing. So, but you know what? That's pretty cool. It's got a pretty long cord. You can see how long the cord is. It's stretching. It's about, God, 2 meters long, I guess, 6 feet, something like that. But yeah, I'm pretty happy with it. Thanks, Micsig. Appreciate it. That'd been nice. They gave me a good discount on the scope, and let me know if you guys want one of those. I think I have a link. I have to find out what link they want me to use, or let me know. I think they're going to give me a discount code. Sometimes those discount codes expire, so let me know. And the Hantek, this guy, for so inexpensive of a probe, this guy is really great. Again, it's only, you know, spec'd up to 20 kilohertz, so it's great for audio band, AC, you know, 60 hertz type stuff, DC. It's great for all that stuff, but, and it's way less expensive. But this Micsig right here, and this other Micsig, that guy, really wide band. Now there's this one that looks just like that. Its little brother that's not quite as wide bandwidth, that's less money. Those guys are kind of, I want to say this guy, I don't know, the price all over the board. I've seen all kinds of sales on them, but somewhere around $300, $400, $500, and the other one is a couple $100 cheaper probably. You have to look every day to see what the price is, and depending on what outlet you go to. But I'll put links down below for the best price I find today. But I'm really happy with this. I'm going to start using it on this project, actually. Alright guys, just thought I'd take a break from the project to do this quick video, because I wanted to pull this out of the box and see if I could use it on the project I'm working on, which looks like I can. So, hope you guys liked the video. Thumbs up helps the video a lot, helps the channel. Appreciate it. It's a kind of a free way to help out the channel. And you can also become a patron for as little as $1 a month. And I want to thank everybody for watching the video, supporting the channel, commenting, all that kind of stuff. And we'll see you next time.